plot of PV by T versus P for 1 gram or 1 into 10 to the power minus 3 kg of oxygen gas at two different temperatures. So you can see there we have a graph which is between PV by T and P at two different temperatures, that is T1 and T2. So we will see these all parts. What does the dotted plot signify? So as we can see here that the value of PV by T in case of dotted plot is constant. So we know the ideal gas equation. The ideal gas equation is PV equals to nRT. So if I manipulate this equation, we can write PV by T equals to nR. Here R is the universal gas constant and its value is 8.314 joule mole inverse Kelvin inverse, and N represent the number of moles and which is constant here. So this the dotted plot here represent the ideal gas, which is true, T1 is greater than T2 or T1 is less than T2. So as we know that in case of real gases, like more the temperature, more it will behave like an ideal gas. As we can see here that this the graph, the plot representing T1 is much more closer than the dotted line. This means the temperature T1 will be greater than T2 because it is much more closer than the much more closer to the dotted line than the T2. So T1 is closer to dotted line, and here dotted line represents ideal gas. Hence T1 is greater than T2. What is the value of PV by T where the curve meets on the y-axis? So we know the equation, which is as PV equals to nRT. Therefore PV by T is equals to nR. Here P represents the pressure, V represents the volume, T represents the temperature, N is the number of moles, and R is the ideal gas universal gas constant. The value of R is 8.314. Its unit is joule mole inverse Kelvin inverse. So as the gas is oxygen and its mass given to us is 1 into 10 to the power minus 3 kgs. So we can calculate the number of moles. So the molar mass of oxygen is 32 gram. Therefore N will be equals to 1 into 10 to the power minus 3 upon 32 into 10 to the power minus 3. This is in kgs. So it will simplify to 1 by 32. So PV by T will be equals to nR, and the value of N is 1 by 32, R is 8.314, and this comes out to be 0.26 joule per Kelvin. This is the value of PV by T where the curve meets this y-axis at this point. If we obtain similar plots for 1 into 10 to the power minus 3 kg or 1 gram of hydrogen, would we get the same value of PV by T at the point where the curves meet on the y-axis? If not, what mass of hydrogen yields the same value of PV by T for low pressure, high temperature region of the plot? And given the molecular mass of hydrogen is 2.02 and of oxygen is 3.32 and the value of R is 8.31. So we know that the value of PV by T is equals to NR. Here R is constant, that is universal gas constant. So PV by T depends on N. PV by T depends on N. As we, as we here have the same mass of hydrogen, that is 1 gram. So in case of O2, having the same mass, that is 1 gram, the value of N was 1 by 32. This is the number of moles. In case of H2, this is again having the same mass, so it is having the value of N as 1 by 2.02. So as you can see here, the value of N, the number of moles in case of H2 is much more than the number of moles in case of O2. And as PV, the value of PV by T is directly proportional to N, so in case of H2, PV by T, the value of PV by T will be higher, hence they will not be the same. If not, what mass of hydrogen yields the same value of PV by T? As we can see here, and we calculated that PV by T equals to 0.26 joule Kelvin inverse. The value of R taken was 8.314 joule mole inverse Kelvin inverse, and the molecular mass of hydrogen given to us is 2.02. So at constant temperature, at constant temperature PV by T is constant, and we know that this value is equals to N into R. So this NR will be constant, and we know that N is equals to small m upon capital M. Here small m is the given mass and m is the molar mass. So m is the mass of hydrogen which we have to calculate. We have to get this mass. So let's see. PV by T equals to NR equals to small m upon capital M R. So we will manipulate this equation, and value of m will be equals to PV by T into capital M upon R. We have calculated that the PV by T in case of oxygen, so the value of it was 0.26. The molar mass of hydrogen given to us is 2.02, The value of R given to us is 8.314. So the value of small m comes out to be 6.3 into 10 raised to the power minus 2 grams. So in kgs it will be equals to 6.3 into 10 raised to the power minus 5 kg. Therefore we need this much amount of hydrogen to yield the same value of PV by T.